All right, welcome to the Math 126 discussion for section 1.7, which is on inequalities. I didn't include this on the discussion, so nobody asked anything. That's my fault. So I'll just do what I think are a pretty good sample of the questions, and I'll end up doing most of them. But let's start here on number 4. Number 4 says solve the linear inequality and express graphically. So I have 4x minus 5 is less than or equal to 5x plus 4. A lot of people, when you have an inequality, like to see that x on the left-hand side, so I'll solve it that way by pulling the x's to the left by subtracting 5x from both sides. But again, if you're okay with pushing them to the right, you can, and that way you don't have to deal with a negative. But that's okay, you have to deal with the x on the other side. Since I'm dragging my x's to the left, I'm going to add 5. Gets that out of there. I have 4x minus 5x as a negative x is less than or equal to, I don't switch it here because I didn't divide or multiply by a negative, 9 on the right hand side. Right? I will multiply by a negative here or divide by a negative 1, it doesn't matter, but that turns out to a positive x, that changes my symbol, and negative 9. Right? And that's it. X is greater than or equal to negative 9 on a number line. That looks like this. Pick a negative 9, right? It's a inclusive, so it's a shaded in circle. Greater than is to the right, and there we have it. That is my answer. Right? Good. Let's look at number 5. 5 says solve the linear inequality, and I have a tripartite here. So I have 5 is less than x plus 5, which is in turn less than or equal to 20. Okay. Now really I just want to isolate the x in the middle here, so I just need to subtract 5, but since it's a 3-part, it's a tripartite, I'm going to subtract 5 from all 3 parts. Right? 5 minus 5 is 0, still less than, x minus, plus 5 minus 5 is just x, less than or equal to 15. And that's it, that's my solution. If I want to graph this, it's just the numbers between 0, not including, but 15, yes including, just the numbers between those. So it would be 0 to 15 in interval notation with a parenthesis on the 0 and a bracket on the 15. Right? And then the solution is basically these two things, these expressions. We break this up and it's 0 is less than x, which you could also write as x is greater than 0, and you would have this x is less than or equal to 15, and that's what we're looking for. Oh, just kidding. The answer is this, where the first, it's weird, this is a weird one. You have a input, drag down, another drag down, another drag down, and another drag down. The first drag down is a bunch of open parentheses. You want the open parenthesis there, and then you're going to type in, well, drag down to 0, then drag down to 15, and then this one is a bracket. So it's a weird way to do this, but that's your solution. Okay. All right, let's look at number 6. So 6 is a nonlinear inequality, and I have x minus 1 times x plus 4 is less than 0. Right? So I can kind of graphically visualize what's happening here. I want the 0 on the right-hand side. We're going to see one in a couple where there's not a 0 over here and what we can do about that. But for now, I know that these two things, if one of them is 0, then the whole thing is 0. If the other one is 0, then the whole thing is 0. But everywhere in between, it's either always positive or negative. So if I say x minus 1 could be 0, that tends, if I add 1, that gives me x equals 1, is a 0 of the function. Right? So on a number line, I'll just plop a 1 down there, graph it, that's a 0. Right? The other one is if x plus 4 is a 0, right? Subtract 4, that happens then at x equals negative 4. So I have a 0 at negative 4, I have a 0 at 1, and this really just kind of cuts my number line into 3 places. A bunch of stuff happening to the left of negative 4, some things happening between negative 4 and 1, and then some stuff happening to the right of 1. But what I know is somewhere, between negative 4 and 1, if I'm positive anywhere, I'm positive everywhere. Because I can't go from positive to negative without crossing over and having a 0, but I don't have one between the two because the only places I have them are at 1 and negative 4. So I have to decide if I'm positive or negative, and I just have to decide that in these 3 different areas, right? So I'm going to plug in a number, say like negative 5 over here, and see if it's positive or negative into the original inequality. So I'm going to plug in negative 5 and see what happens. The negative 5 minus 1 is negative 6. Negative 5 plus 4 is negative 1. Is that less than 0? Well, negative 6 times negative 1 is positive 6, which is not less than 0, right? It's positive, which does not solve it. It's not less than 0. We're looking for the places where it's less than 0, and that's not here. Right? Some number between negative 4 and 1, like say 0, is here, right? So I can plug in 0 and see if that solves. So if I plug in 0, that gives me 0 minus 1 is just minus 1. 0 plus 4 is 4, and negative 1 times 4 is negative 4, which is indeed negative, and therefore is less than 0, so it solves it in this region between negative 4 and 1. I have one last region, somewhere to the right of 1, like, say the number 2. And if I plug in 2 into here and see what happens, 2 minus 1 is 1. 2 plus 4 is 6. Well, 1 times 6 is 6. That's a positive number. It is not less than 0, and so this doesn't solve it. So the only places that this solves are between negative 4 and 1, but not including because it's a strict inequality. So my solution would be then negative 4 to 1 with parentheses around both. Let's look at number 8. Eight says I have x plus 2 divided by x minus 3 is greater than or equal to 0. Okay. So graphically what's going on here is the same thing. I'm looking for places that I have zeros. And you can see if my x is negative 2, that gives me a 0 in the numerator. And so I have that negative 2 here, and that's a 0. And I'm going to mark my 0 with a dot here. I also have an issue when x is a positive 3, because then I have 3 minus 3, which is 0, but it's in the denominator. So it's not a 0 of the function. It's not in the domain. So at x equals 3, I have an issue. So I'm going to just mark it with an open, right? If I mark it with a closed here, that means it is a 0. If I mark it with an open here, it's not a 0. It's not even part of the function. It can't be it's excluded from it because of the domain here, right? But it still cuts me into 3 fields, or 3 areas, right? 3 intervals. So if I test these out, I can test out a number to the left of -2, like say -3 is over here. If I plug in -3, I get -3 plus 2, which is -1, over -3 minus 3 is -6. Is that greater than or equal to 0? Well, yes, because the negatives cancel out. And I get 1/6 is greater than 0. This thing is positive. We're looking for it to be positive, so this is a solution interval. I then want to check a number between -2 and 3, like, say, 0. Right? And if I check 0, let me erase this little scratch over here and try 0. If I try 0, that gives me 0 plus 2 is 2, 0 minus 3 is -3. That should be greater than or equal to 0, but it's not because 2 divided by -3 is -2/3. And so that's negative down here, and it is not part of the solution because it's not greater than or equal to 0 in this interval. I'll then check a number over here to the right of 3, like, say, 4. And if I plug 4 in, I get 4 plus 2 is 6. 4 minus 3 is 1. Is that greater than or equal to 0? Yes, it's 6 is greater than or equal to 0. And so that's part of the solution as well. And so then my final solution, I'll let you write this, is the union of the interval from forever to the left up to -2, including, right? And then from 3, in fact, screw it, I'm going to write it so I can explain it. It goes from -infinity up to -2, and -2 is included because at -2 it is 0, and I have an inclusive inequality. I have this gap in the middle, but then I'm going to start back up at 3, but 3 was not in the domain because it's not allowed. And so I don't have a bracket on 3, I have a parentheses, and then this goes off to infinity, and we have that interval, and that's our interval notation. Okay, good. Let's look at 9. 9 says, is similar. I have 2 plus x over 2 minus x needs to be greater than or equal to 1. Now, everything that we've been doing is dependent on that 0 factor law that says you have zeros at wherever the multiplication of these things ends up being 0, which if you have factors, one of those factors has to be 0. Which means that I need a 0 on the other side here, right? And it might be easy to say, well, just multiply 2 minus x up to the other side and then move on. But the problem is I don't know if 2 minus x is positive or negative. If it's positive, I can do that and I'm fine and carry on. But if it's negative, I need to flip this sign and then I can do that and carry on. But again, x can be anything, so it's hard to define whether this 2 minus x is positive or negative from the get-go. So instead of doing that, what I'm going to do is subtract 1 from both sides. And so this gives me 2 plus x. This looks like a big ugly fraction when I do that. I'm going to get rid of that. Maybe do this. I don't know. Is that worse? But I have 2 plus x over 2 minus x, and then minus 1 is now greater than or equal to 0. So I've got the 0 over there. That's good. I need that. What then I need to do is get rid of this fraction minus a whole number. But remember, I can treat 1 like a fraction. It's 1 over 1, right? And I can combine these two as long as I have a common denominator. Which means I can multiply 2 minus x to the top and to the bottom. And I get that for free because 2 minus x over 2 minus x, it doesn't matter if that's positive or negative. It's, in fact, 2 minus x doesn't matter if it's positive or negative because if I divide it by itself, it's 1. This whole thing is 1, right? And that's what allows me to do this. So this gives me 2 plus x over 2 minus x minus 2 minus x over 2 minus x greater than or equal to 0. Right? And if I combine this all into one big ugly fraction over a 2 minus x, that's 2 plus x minus 2, and this minus gets distributed, so I have plus another x is greater than or equal to 0. I'm going to get rid of some of this stuff up here, so if you need to pause it, go now. I'll combine this. I have x plus x is 2x. My 2 and minus 2 cancel out in my numerator, and then I have 2 minus x in the denominator. And that is greater than or equal to 0. Okay. And now I have it in the form that I want it. I have a simple fraction relative to 0. It's greater than or equal to 0. So I can look at what's happening. For my numerator, it should be pretty clear to see that if x is 0, this whole thing is 0. So there's my start point. Is at 0, I have a 0. For the denominator, 2 minus x can't be 0, right? If I add x to both sides, then x can't be 2. 2 can't be 2. That's helpful. X can't be 2, right? And so at 2, I have that cut. It's an open because it isn't actually a 0, and then I just have to test my values, right? I'm going to leave this one here because it's then the same as number 8, I think, that we did. You should be able to take this one from here and then turn it into an interval and turn it into your solution. But that's how I would treat number 9, is to go through that process to turn it into something that we can do like we did in the last questions. Let's move on and take a look at number 10. Says the temperature in Celsius, x meters from the center of a bonfire, is given by T equals 600,000 divided by x squared plus 300. Okay. At what distances from the fire center is the temperature less than 500 degrees? So the question is asking this. We want to know where the temp is less than or equal to, less than, strictly less than, 500. But the temperature is that expression there, right? And so that turns into 600,000 divided by x squared plus 300. That temperature, we're looking for where that will be less than 500, right? Now, the last problem I did, number 9, was it? I didn't want to multiply my denominator up because I couldn't guarantee that denominator was positive. If it's negative, that's where I would have an issue, because if I multiply it up, it changes my inequality. But x squared is definitely a positive number. And if I have whatever positive, maybe not, it might be 0. But the worst case is 0, but I'm adding 300 to it. This x squared plus 300 is guaranteed to be positive. This is positive. I'm positive of it. Oh, that's the worst. I'm not going to do that one. But if I multiply this up, it's free because I know it's positive. So that's what I'm going to do. So I've got x squared plus 300 multiplied both sides, multiply it here, which cancels out my denominator and leaves me with 600,000 on the left-hand side. is less than 500, and I'll just distribute this, 500 x squared plus 150,000, that is. So I can subtract 150,000 from both sides. Right, I'm going to carry this up, so if you need to write, pause it, because here it goes. So this gives me 450,000 on the left is less than 500x squared. Right. Now I've got an x squared here, right? But that's okay, I'll deal with that in a minute. I'm going to divide each side by 500. Everything that I've been dealing with here is positive numbers, so I don't have to worry about any switching of the signs. That gives me 90. Right? 9, by which I mean 900, right? And now I have x squared has to be greater than 900. Well, x squared is definitely a positive number, and I don't really have to worry about the negative possibility here from the x being possibly negative. Because that would mean I got so close to the fire that I went into it and have negative distance from it, which is going into a different dimension. We don't have to worry about that. The closest we can get to the fire is 0, right? So I don't have to worry about negatives here. I don't have to worry about the fact that this is, a two-sided interval. All I have to do is take the square root here and say, because it's a real-world value problem, I only have to worry about that one side. X has to be greater than 30, and so the distance is greater than 30. And I'm looking at your options here. There are two options. It says greater than or equal to, but the wording in the question specifically says, at what distances from the fire center is the temperature less than 500 degrees? And so to be less than, that is that strict inequality. And so the x has to be strictly greater than 30 meters. All right. Hope that was helpful. I will see you guys next time for 1.8.